This is Madhuri Bhamadipati. Today I'm going to show you the demo of my project for the course Image Processing and Computer Vision taught at the University of Florida. Well, my project is based on feature-based image segmentation. In this project, I'm going to compute the matching points between two different images using the feature detectors and feature descriptors. So, for this project, I've taken 6 different detectors and 6 different descriptors. For the various combination of detectors and descriptors, today I'm going to compute the matching points for different images, and I've written my code in MATLAB. Well, uh, in MATLAB, I've created a very small functions which take the input image, and then with the help of the detectors and the descriptors, we would now compute the matching points. So, I have written a small function which is nothing but a GoBundler function. Let me open it for you in a while. So, in this GoBundler function, you will be calling the file name as in the image and the detector and the descriptor. So you'll be passing 3 parameters: file name, the type of detector used, and the type of descriptor I used. So let me show you a live demo of that. How does the GoBundler function work? Well, now let us go to the GoBundler function. As you can see here, I'm taking the input as 3 parameters: the file name, detector, and descriptors. These are the different descriptors and detectors used. Let me go to the data. You can see that the data has different names. You're giving different inputs in that, and thus you'll be computing the key points. So for my project, I have chosen 6 different sequences. Let me show you the sequences now. So these are the different sequences: bark, bike, boat, graph, living, and tree. So now these different images from the different sequences are used, and with the help of the descriptors and detectors, we find out the matching points for these different images. Well, now let's take a single sequence image. Let us consider the bark1 image. When you let us see what happens when you consider the bark1 dataset. So here I have like the different descriptors and detectors and like lots of unwanted stuff. So let me clear it off initially. And going to the terminal, I would show you how to take the input image file, like the bark1 image. We thought to take the bark1 image matching points. So let us go to the bark1 image now. Navigating through different folders, and let me go to the desired folder. So here you can see that the different folders are listed. So as we have the code, the image is stored inside the folder of bundler, and here you can see that there are different images. So now we are going to open the image which we want. So in Bhag1 dataset, you can see that there are different images. Here you would be considering the image 1, and then so basically in this sequence you've taken the input image 1, and as you're finding the histogram of that, so now let us see what would be the outputs. I'm just removing the unwanted files. So now we are having a, in the end you would be having a descriptor, a director, and a single image file. So here when you consider image 1, and let us consider the image 2 as well. So considering both the images, now we can find the matching points by using a desired descriptors and deductors. So initially when we have the images, we need to select the deductors and descriptors needed. Let us go back to the GoBundler function and then select a particular descriptor and a deductor for the input image file. So here I'm considering the Bark1 image along with the Harris J deductor and Swift descriptor. So now we would be navigating to the folder path. Now when we execute the GoBundler function, you can see, uh, just a minute. So here in the function you can see that it contains different deductors and descriptors. So here you need to give the data set in a as the input. Let me run the Gobandla function once again. So as you pass on the three parameters like the bar image, the detector and the descriptor, you can see that the key points are being computed. And for various images given as the input, we could actually calculate the matching points. Here you can see that the key points are being computed for image 1 and image 2. So here like the CSV file now which have been created is the matched key points. Similarly, we need to consider the different sets of images like image 1, image 2 and image 1, image 6 for an example. So here you can understand that the images used are image 1 and image 2, and the detectors and descriptors used are Harris J and SIFT descriptor. So in this manner we calculate the matching points for various images using different sets of combinations of detectors and descriptors. So here you can actually see that a match plot has been plotted. So you give the input image name, file and the path name. You would be getting a match plot for the input dataset image and the generated CSV file using the detector and descriptor which we got right now as the matching key point. So now you can see that there are matching done between two different images. So this is how we find out the matching for different images using this technique. You can use various detectors or descriptors, and another set of matching key points would be generated, which is another CSV file, and hence in this way you can get the matching key points for different sets of images. So this is for the same set like image 1 and image 2 but different detectors and different descriptors. So it depends on the size of the image you take So here you can understand that in the data for the various input images, you could calculate the key point using the detectors provided, like the other descriptors: Harrison Laplace, Hessian affine, Hessian Laplace, and so these are the different descriptors and those were the different detectors. This is how I've done my project for computing the different matching points using various sequence of images and 6 detectors and 6 descriptors. Detailed graphs and matching points of my project have been provided in the report. Well, thanks for giving me this opportunity and thank you.